Darboux's theorem, very important theorem on calculus. So what is the statement? So if a function f is derivable on closed interval ab and f dash a, f dash b are opposite signs, then there exists at least one point c between a and b such that f dash c is equal to 0. Okay, so now we shall prove of this theorem. So for the sake of definiteness, let us consider f dash a less than 0 and f dash b greater than 0. Okay, so since f dash a is less than 0 means negative, therefore there exists a positive real number delta 1 such that f of x less than f a for every x belongs to this open interval a plus delta 1. Okay, again here since f dash b is positive, so again since f dash b is positive, so there exists a positive real number delta 2 such that this f of x less than fb for every x belongs to this open interval b minus delta 2 and b. Okay, so this is second. Also, since given here f is derivable in closed interval ab, it means since we have every differentiable function is continuous, therefore f is continuous. Therefore f is continuous in closed interval ab. Being continuous in this interval ab, it attains bounds because every continuous function is bounded. What is the definition of bounded function? If attains lower bound and upper bound. Since if a function has lower bound, it means this has greatest lower bound, and similarly for upper bound it has least upper bound. Okay, so let m is a greatest lower bound of fx, then there exists a point c in closed interval ab such that f of c is equal to m. Okay, it is clear from 1 and 2 c coincide with a and a or b. Okay, since by 1 and 2 and this is 3, so from 1 and 3 c cannot coincide with a or b, for otherwise there would exist points where the values of the function would be less than fc. Okay, the c is an interior point of ab. Okay, now we proceed to show this point where f dash c equal to 0. So there are two conditions. So now if f dash c is less than 0, then there exists an interval c plus delta 1 where delta 1 is positive real number. Since I have taken delta 1, so we will take here delta 3, and delta 3 is greater than 0 such that for every x belongs to this open interval c plus delta 3. Okay, and fx less than fc is equal to m. And this is a contradiction. Okay, it means, which is a contradiction for the fact that m is infimum of fx. Okay, that infimum of fx is equal to m. Again, if we take f dash c positive, so again, if f dash c is positive, then there exists an interval c minus delta 4 and c, where delta 4 is positive real number, where delta 4 is positive real number. So for every point x of which fx less than fc is equal to m, which is again a contradiction, which is again a contradiction. Okay, because m is a contradiction of infimum of fx is equal to m. Contradiction of infimum of fx is equal to m. It means the only possibility that f dash is equal to 0, f dash c is equal to 0, f dash x is nothing but f dash c. Okay, where c lying between a and b. So this is the theorem.